Hello everyone, my name is Inga and I'm pleased to welcome you all to the webinar Product Line Engineering with Cameo Systems Modeler and Pure Variants. This webinar overviews the basics of product line engineering, but mostly focuses on demonstrating the integration between Cameo Systems Modeler and Pure Variants from Pure Systems. The session is hosted by Darius Petrauskas. Darius is a solution architect at NoMagic, working with software engineering and enterprise modeling solutions. He is also an OMG certified UML professional. Before joining NoMagic, Darius acquired substantial experience in operational analysis and improvement, consulting, project management, and designing various software and hardware systems. At NoMagic, he does training for local and international public and private sector enterprises. Before Darius starts, let me remind you that today's presentation and demo will take about 50 minutes and the question-answer session about 10. And if you have any questions, you don't need to wait for the question-answer session to ask them. You can do this during the entire webinar and Darius will answer them later on. All you need to do is type your questions in the questions area. However, due to limited time, some questions might be left unanswered. In such case, we'll provide the answers later on the webinar's webpage. So Darius, are you ready to start?
Yes, Inga, thank you for the introduction. I'm ready to start. Let's begin today's webinar by overlooking the agenda. And first, I just have a few slides for you prepared explaining what PALE is and why should you use it. Then we have to overview the integration between Cameo Systems Modeler and Pure Variants, which models reside where and which models have to be created. And then we'll switch to the tools for the actual demo, after which we will have a brief Q&A session. So what is it all about? Actually, today's webinar is to present a top-down PLE case and provide for you a good starting point for using PLE with Cameo Systems Modeler and Pure Variants. And we will do all of the things listed here, like creating feature and product models in Pure Variants. Then we will be linking the product models to the system model in Systems Modeler. And then we'll define the necessary variation points in the system model. And then we will realize specific variants of the products described in the systems model. So today we'll be using for the demonstration, of course, the Cameo Systems Modeler, which is essentially Magic Draw with Cameo Simulation Toolkit and SysML plugin in a bundle. And the other tool we'll be used today is by Pure System. It's called Pure Variants, and it's variant management software for complex systems and software engineering. And I think it's worth noting here that Pure Variants and Cameo Systems Modeler can be used not only for systems engineering, but also for software engineering, UML, and other modeling domains that are supported by Magic Draw. So let's move on and let's talk about product line engineering. So what is product line engineering? Basically, it is the engineering of a family of related products. So what do I mean by related products? So imagine you have a coffee machine. One coffee machine makes coffee with milk and another one makes coffee without milk. So you have two related products in the same product line. And before actually producing a coffee machine, you have to design it. And you end up with various digital artifacts, for example, requirement specification, system models, documentation, and so on. And you have to manage all of those artifacts. So PLE focuses on managing commonalities and variabilities in the product line. So if you have two coffee machines and one makes coffee with milk, so you can imagine that they have a lot in common, and only the difference is related to the milk part. So product line engineering tools and this engineering discipline manages all that. And by using a PLE tool, you can also automatically derive products from this common product family. So why should you use it? So imagine that you have not 2 variations of a coffee machine, but 10, each making different coffee, each with different components. And if you would have artifacts describing this coffee machine separately, so for example, you would have 10 requirement specification, 10 system model. Then as time moves on, you would have quite a nightmare to updating and maintaining these artifacts. For example, if there is a change in the system, you would have to manually update each artifact, or for example, if multiple teams are working with the specification of the system, and one engineer makes a change for a specific variant, and others are left not updated, then you have immediately some problems with your product line management. And by using a tool like Pure Variants, it's also possible to automatically generate product models, and we'll be talking about that today. But I want to mention that this doesn't only cover the modeling domain. You can also have variant management for requirements, for documentation, for source code, and so on and so on. But today we'll be focusing on the domain of the system modeling domain. So now let's see how the integration between Pure Variants and Cameo Systems Modeler looks like. So first we have a feature model describing our domain. And this is where we define the commonalities and the variabilities of our domain. In our case, it will be a coffee machine. Once we have that, we can begin creating our actual products with those specific features described in the features model. And then we switch to the Cameo Systems Modeler side, where we will have a system model for the entire product family. So I like to call it a 150% system model. And by using the variant description model from Pure Variants and this 150% system model, we can derive automatically a product system model for a specific variant. And also what is possible to do in Pure Variants is to create a family model where all of those different artifacts for different domains like requirements, documentation, system models, etc. will be managed. So we'll be looking over that during our demo. So what is the domain today and the sample today for the presentation? So I'll be using our standard coffee machine sample, but we need to keep in mind that we are dealing with different variants of the coffee machine, so I identified a few of them. So first we'll have a coffee machine targeted for many markets, so that's one set of variations. And we'll have a coffee machine, we'll have 2 editions of coffee machine. One will be the standard and the other one will be deluxe. And they will have different coffee brewing options. And note that if we have an Indian market, a coffee machine for Indian market, then we would need a coffee grinder for a high humidity environment. If we would have a coffee machine for the European market, we would need a coffee grinder with low humidity. So we once again add a few variabilities. And just as another feature, we'll also be adding a power adapter and maybe also adding an optional LCD screen for displaying status and other relevant information. So I think this is enough of the theoretical part, and let's switch in this case to the tools, not just one tool, but to Pure Variants and Cameo Systems Modeler, and realize a few variants of our coffee machine. So before we do that, I just want to go a few steps backward and show you that we begin here, because everything else uses this feature model, so we can now go to Pure Variants and begin creating a feature model for the coffee machine. So I'm starting from scratch and explaining everything all the way through. So to begin working, I first need to create a variant project. So I'm creating an empty project and I'm naming it, let's name it Coffee machine webinar. And I'm explicitly making it empty, so I will create everything inside as we go, explaining why I'm doing it and what it means. So that's all I need to do here. And I have an empty project. This project is currently empty, and in this project, as mentioned before, I need to begin creating the feature model describing my coffee machine. So it's pretty easy to do. I select new and feature model. And I once again need to name it, and I'm naming it coffee machine features. So all of the features, the commonalities and the variabilities will be described here in this feature model. Okay, so immediately I have a root feature called coffee machine feature. So the feature model is structured like a tree, and let me show you how it works. So I have my coffee machine. So I need to define all of the features that will be common and variable in the case of our presentation. So let's begin by creating features describing the target markets for our coffee machine. So I'm creating a new feature and I'm naming it market, and there are a few options here, and these are important. So you can have 4 variation types. You can have a mandatory feature, so this would be your commonalities, and 3 not and 2 optional feature. Sorry, 1 optional feature, which means that the feature is optional, so 0 or more features at this level can be selected. We can have alternatives, so meaning that at a particular level only 1 of the features can be selected. And we also have an OR type, which means that 0 or many features can or cannot be selected. So we can leave all of the other fields here not filled, but Pure Variance is very flexible tool, and I encourage you to check it out on your own. So let's say that, okay, we have our market, and in the market I'm creating another subgroup of features, and if you remember from the slides, we have 4 markets. So 1 market will be for Europe. 1 coffee machine will be designed for Europe, so this will be an alternative because a coffee machine will be designed for a specific market. And in the same way, I need to create features describing additions for other markets as well. So another one for USA, also another feature for India, and another feature for Australia. Good. And now we have a mandatory feature market which has 4 alternatives. So I could either choose Europe, USA, or any of these markets, but I cannot choose 2 of them. Okay, so I have a market, and of course I need also to create an addition. So I'm creating it as a feature. This is a mandatory feature because I must have an addition. So I'm doing it much like the same before. And for the addition, we'll have 2 alternative additions. So one will be the standard addition, and another addition will be called, let's name it Deluxe, with many coffee brewing options. Okay? So I have the addition, and if you remember, India has a humid climate, so I need a coffee grinder specifically for high humidity environment. So I need to create a feature, a coffee machine feature, and name it coffee grinder. Yeah, and this of course is a mandatory feature because a coffee machine must have a coffee grinder. And as sub-features, I need to create 2 grinders. So one will be low humidity grinder. This will be also an alternative feature. And another feature will be called, I'm sure you guessed, a high humidity grinder. Okay, it's also an alternative. Okay, I have my grinders in place, and we need to create the power plugs because it was, as you remember, also mentioned here for the specific domain. So we need to have power adapters. So one for the low voltage, middle voltage, and one universal. So let's do that. Let's create a new, again, mandatory feature called, let's call it power adapter. Adapter, that's it. And we can have 3 types of power adapters. So one will be adapter 120 volts, so for the United States. This will be an alternative. Another feature for the power adapter of adapter 220 volts. And let's also make a feature called adapter universal. So basically it's more expensive, but it works in Europe and in America and elsewhere. And basically that's it, and just for the sake of completeness, let's just add an optional feature. Let's make it optional, and this will be our display for the coffee machine. So the coffee machine can come with a display to display relevant information. So we also have an optional feature. So pretty much this looks pretty good already. I can also view my feature model in a graph structure, but I prefer to work with a tree. And now I want to also show you a cross dependencies between features. So for example, I could define that deluxe edition of the coffee machine must come with a universal power adapter and also include a display. So how could I do this? I can do it really simply. I need to add a few relationships, cross relationships between my features, and I need to say that I would require the deluxe edition of coffee machine would require a display, and it would also require a universal power adapter, so adapter universal. So once I do that, and if I go back to the graph, I see that my deluxe feature has some requirements. If I hover over the deluxe feature, I'm switching the tooltips on so they do not distract us. If I hover over the deluxe feature, I see that this feature requires a universal adapter and a display. So basically that's it for our feature model. And if we go back to the slide once again, we see that once we have the features, we need to create models for the different product, for the actual products that we want to describe. So in our example, I will create 2 products for the coffee machine. One will be for the European market and it will be a standard edition, and another one will be for the Indian market, and let's make it a deluxe edition. So we'll create 2 products based on the feature model that we have here. So to create the product model, it's pretty straightforward. I select new, and in this case not a feature model, but I will need to create a product model. And in pure variants, product models reside in what's called the configuration space. So first I'm creating the configuration space, and let's name our configuration space. Let's name it coffee machine. Let's name it clear variants. So I have many different variants of my coffee machine, and this will be the configuration space, and I can leave everything else default. And in this configuration space, I am now creating what is called a variant model. So we'll create a specific variant of the coffee machine. So let's create the first one, and it will be European standard. It will be a European standard edition of the coffee machine. Click finish. And what happened now? Now I have a product model, which is called variant description model by the file name, and I immediately get some validation errors. And this is because it is saying that we have some open alternatives. Okay, so let's fix that. So I have an edition. I'm saying that this is a standard edition, yeah, and it automatically, as you see here, this selects the second feature. And what I also need to else specify. In Europe, we have a dry climate, so I need a low humidity coffee grinder. And for the power adapter, let's say that I need a 220 volt power adapter. And of course, this coffee machine is designed for Europe. And this is all that I need to do. And the standard edition will not have a display. Okay, so let's create another product. Similarly, like we did before, I'm creating another variant model, and let's name it Indian Standard, Indian Deluxe, sorry, and it will be a coffee machine for the Indian market. Okay, again, click finish. And now I'm first selecting the market that will be for India, and immediately I select that it is a deluxe edition, right? And the tool automatically fixes everything so that everything is according to the rules. So for example, I can only have one alternative. And if I have a deluxe edition, then immediately, let's just say that it's a first that we need to use a high humidity grinder for India, but it automatically suggests for me that I need a universal adapter, because as you remember, I've specified that the deluxe edition would require a universal adapter, just as an example, yes? So I'm selecting a universal adapter, and I also selecting the display. So basically now we have a feature model describing our coffee machine domain, and we have two models for the product. So one coffee machine for Europe and one for India. And also if I double click on my configuration space, I can also edit and tweak my product models in this matrix format, but I preferred to do it in the tree. Okay, so basically, let's once again go back to the slides. We have a feature model and we have a variant description model. So we are pretty much set to go to Cameo Systems Modeler side. And let's do that. And a few comments about this 150% system model. So this system model is describing all possible additions, so all possible features, all of the commonalities and variabilities of my coffee machine, and these features are modeled here in the features model. So if I switch now to the Cameo Systems Modeler, I have the coffee machine project open, and before the webinar, to save time, I have prepared this 150% model. So let's just focus here on the structure side, because this model is quite huge, but the structure side will be sufficient for this demo. And the coffee machine, as you see here, has many different parts. And the parts shown not in compartments but in the diagrams is actually our variabilities. So as you remember, we need a coffee grinder. So now this 150% model has an abstract coffee grinder. So it has a part. If I select my coffee grinder in the containment tree, I see that my coffee grinder part is typed by coffee grinder block, but this is an abstract block. And I have two concrete grinders. So one for the low humidity environment, other for the high humidity environment. And it has some values, some default values, which are used in the simulation process. So I have a grinder. I also have a power adapter. I have three of them, as in my feature, as described in my feature model. And you maybe remember that we have also added an optional feature which is called display. Yeah. So I'm adding also here as a part to my coffee machine. So let's leave the model for a little bit, and I need to explain to you an important topic is to what do you need to have to be used this integration between Cameo Systems Modeler and Pure Variants. So of course you need to have Pure Variants installed. An evaluation version is available for you to try out, so you can contact Pure Systems directly. And once you have Cameo Systems Modeler, which has also an evaluation version, once you install it, you have to install 2 additional plugins before you can begin working with product line engineering integration with Pure Variants. So these 2 plugins are free. They're under the no-cost group, so you need to install 2 of them. One is called Product Line Engineering. It is the base for Product Line Engineering, and we have another specific plugin for Pure Variants integration. So you need to install 2 of them, and basically you are set. So you select it and install, they're free, and you are done. And there is another one important bit that I need to explain, because right now if I would click on my block, I would not find any way to describe, to define the variation point in my model. So I cannot now define any variabilities. So to do that, there is one step when you begin creating your 150% model. So you need to do a simple step. You have to use a profile, a Pure Variants integration profile, which allows this integration to work, to put it simply. So I need to use a local project, go to Profiles, navigate to Pure Variants profile, and leave everything at the default, and simply click Finish. So once I do that, the tool will load the Pure Variants integration profile, and I will not show it in the containment tree. And now if I right click on a block, a new menu group appears here, Pure Variants, and here I can begin defining variabilities in my 150% system model, which I have here. So first of all, I would need to explain to you what different types of variabilities exist in a systems model modeled in SysML. So first we have an existence variation point. So the existence variation point means simply if a feature is present or not present, then the element to which this variation point is associated with is kept or deleted from the model. So for example, if we have a feature called display, then we have the display will remain in our model when we realize a specific product. If we don't have, then it will be deleted, and I will show you this later on. Another variation point, we have 2 of them actually, called primitive property and element property. So primitive property would set a primitive meta property with a primitive type for a standard meta class. So for example, if I wanted to change the name of this block, I would use a primitive property. And I also have an element property. So if I have to type my property with an element, with another modeling element, so for example, if I would need to type my coffee grinder, yeah, so I would use this variation point to set its type, and I will demonstrate this in a few moments. And we have 2 similar variation points here. They're called primitive tag and element tag, and they are essentially for extensions, so for stereotypes. So for example, if you would have a SysML requirement which has a stereotype, yeah, if you would need to change its text, then you would use primitive tag. If you need to change its type, then you would use element tag, and I will demo all of these variation points in just a moment. So that's about the variation points, and what I need to do now is to link this model to the feature and product model that we have created in Pure Variants. So we have, once you install the plugins, we have a pure variants tab here, and we can open what is called the configuration space. Remember, all of our products reside in the configuration space. So the configuration space is located in the project Coffee Machine Webinar, Coffee Machine Variants, and here we have the configuration space. And if I open it, I immediately see my two products, yeah? And before I select them, I see the same feature model that I saw in pure variants, yeah? So it's pretty straightforward. So now I could choose a European standard coffee machine and or an Indian deluxe, yeah? And depending on which product I choose, different features are selected as we have defined here in pure variants. So now what I would need to do is to somehow link those features with the system model describing the entire product line of coffee machines that I have. So how do I do that? Remember that I have already talked about the variation points. So now I need to begin defining those variation points in my model. So let's start with a simple existence variation point and define the variabilities that should be in my model. So it's pretty easy to do. So let's begin with the display and add our first existence variation point. And once I click it, the tool, the integration opens up what is called an expression editor, and we can write expressions. In this case, we need an expression to evaluate true. And for how to write the expressions, you can click on this icon right here to bring up the description for the syntax for the expression editor. But it's pretty easy to do. So for the display variation point, all I need to do is to begin writing display, press Control space or Command space on a Mac, and the expression editor figures out that there is such a feature called display and automatically does the work for me, and I only need to simply click OK. So now what is happening here? Why it is highlighted? So if you see here, I have selected the European standard product, and I have this toggle here to disable or enable transformation previews. So if I disable it, I do not see anything. If I enable it, I see that in the case for European standard, it has no such feature of display. This will be deleted. If for an Indian deluxe, display will be kept because it has such a feature. So this is a very, very basic principle, how it works. So let's move on and define the existence variation points for our other blocks and other features. So for the low voltage adapter, I define one variation point. I also add another existence variation point for my other adapter, and this is the 220 volt. I also need to add an existence variation point to my universal. So begin typing adapter universal and select it here. So that's basically done for the power adapters. Let's just switch the toggle off so it doesn't distract us. I need to do the same thing to add the existence variation points. In this case, one for the low humidity grinder and another one for the high humidity grinder. So it's pretty straightforward to do. So if this feature is present, then the expression evaluates true, and if it evaluates true, it does not get removed from the model. So basically we are done with the existence variation points, but I also need to move on now to the other variation point and to change the type for my coffee grinder. So depending on what kind of coffee grinder do I need. So how can I do that? So now I'm creating, as I mentioned before, an element property variation point. So what does it mean? So if I select it, it now will change a type. By default, it defaults to type, and that's what I need to do. It will now change the type of my part. So now I need to specify the conditions and the elements to type my part with. So as previously, first I need to type my part with a low humidity grinder if I have a low humidity feature, and I need to select an element from the model for the type, and let's just do a quick search. In this case I need a low humidity grinder, and it is here in my model. So for the low humidity grinder feature, the element for my part type will be low humidity grinder, and let's add another one for the high humidity grinder, and simply in this case say that I need a high humidity grinder block to type my part with. I have it right here, select it, go back, and I have my variation point all set up. So now if I enable the transformation preview, I see that for the European standard I would have a low humidity grinder, and the high humidity grinder would get deleted. My part will change the type, and I can also immediately see in the other views where the part is used. So in the thermal view, for example, the type for the coffee grinder will be changed because I have an integrated model. And before we move on, I also want to show you another thing. And since this model is executable, so if I would run simulation for this model, I would be able to see the user interface for the simulation of the coffee machine. And here I see that I have a 150% model. So let's fix that, and to specify that this would be a standard deluxe edition, and the standard edition, let's say, would only be able to brew espresso or cappuccino. So let's also do that in the model. So I'm switching to the user interface mockup in the model, and I need to define a few additional variation points for this graphical user interface. So first I need to deal with this bit, and since this is a label, here I'm selecting it in containment tree, and if I look at the stereotype, it's a stereotype class essentially. So for this element I need this other type of variation point. If you remember, it's called primitive tag because I want to set a tag for a stereotype. So I'm selecting it, and simply I need to write an expression. So if my addition is deluxe, then let's add a string here. So let's name it deluxe edition, or else it will be, let's just make it simple, standard edition, and do an end if. And this is our expression. The expression is finished, and I need to select a tag to which I'm setting this string for. So in this case I want it to be the text, and that's it. That's all I need to do. And the last bit is I want to get rid of these 3 coffee types for the standard edition. So only make them available for the deluxe edition. And for more advanced users of Cameo Systems Modeler, I want to show you how you can reuse the constraints and apply them to many elements and not create each of them individually. So I'm quickly creating a package to hold my constraint, and let's say that here I would have my variation points. And let's select the first element and create a simple existence variation point for the deluxe edition. So if deluxe edition is present, then this element would remain. So if I now expand this element, I see that this is the constraint, and all of the variation points are basically constraints, stereotype constraints. So I can simply reuse them. And how would I do that? I would simply drag my constraint to variation points and then open up. If I would open up its specification, I could constrain many different elements with the same variation point. So let's do for all of them here really quickly. So I'm selecting them in the containment tree, and by holding Control and dragging to the constraint element meta property, I'm simply just with this quick way constraining all of those different elements. So let's quickly do that. There are a few more remaining. I need to also constrain this one with the same variation point and this last one. So I have 6 elements now constrained by the same variation point. And this variation point resides here. So basically, these are all of the variation points that I need to define in my model. And now I think the obvious question is how to use the variant description model and this system model for the entire product line to produce a specific product or specific edition of our coffee machine. So to do this, we need to do what is called a transformation. So let's say that I want to realize my European standard edition of the coffee machine that I have here, described with this 150% model. So let's just toggle the preview off, and I need to perform what is called a variant realization. So to do that, it's pretty straightforward. I need to go to Model Transformations and to select a variant realization. This is a specific transformation to realize a specific product of my coffee machine. So I'm selecting all of the data that I have in my model. You can specify the scope here for the transformation. Click Next. You do not need to set any type mapping. And in this lab step, since we're using pure variance, we are choosing pure variance as a variation data provider. And we have an option to clear the variation points after the transformation takes place. And that's the case what I need to do here. So pretty simple. All that's left to do is now to click Finish. So now what the tool does is goes over the model and looks for the elements which are constrained by the variation points. So it looks for the variabilities in my model, and based on the feature model and on the product model that I have defined in pure variance, it will make the necessary transformation of the model to be specific for a specific edition of my coffee machine, in this case for the European standard. Yeah, so voila, you see that the display is gone. It was removed from the model, and we can also see that the type was changed to a low humidity for the coffee grinder to a low humidity grinder, and the high humidity grinder was removed. We can also see the changes in the other views, and if I would now try to execute my model, remember that we also modified the user interface of our executable model. We see that we have a standard edition of the coffee machine, and this is something true of here, sorry about that, but these elements should also have been removed. I'll check what the mistake I've made here. But basically the principle should be here. Maybe I've set an incorrect variation point in my for my GUI. And yeah, so my variation point was thrown here a little bit, but let's just quickly undo a few steps and see what happened. Okay. So this was an incorrect variation point was moved here, and let me quickly just rectify this situation. So I need to move this variation point back here, and basically the variation point was defined incorrect in this case. And if I open up here, then I would need to, let's just quickly do it to make it correct and make it proper, so that you get the idea. So basically I did it wrong. I needed to create an existence variation point for the label, and let's quickly do it for the deluxe. Yeah. So I'm creating for the deluxe existence variation point here. Yeah. So this is the constraint that I should have moved, and I already have it in the model. So if I move it once again here and quickly open up the specification, and quickly I can redo all of the steps so that we can have a model without errors. So let me quickly do that once again, and sorry about that, but let's fix this mistake and do not leave it. Let's do it like this. So I'm constraining different elements with the same variation point. So it's pretty easy to do that. And this is the last one. And if I go back once again, and let's quickly again do the same transformation to realize the standard edition of my coffee machine. Yeah? So let's give it a few moments and see what happened now. Now I did everything correct. So if I now execute my model, I see that I have my standard edition of my coffee machine realized, and the deluxe coffee brewing types were removed. So I could play around with my model and execute it, but unfortunately we do not have the time. If you want to, you can check out the engineering analysis on SysML models webinar to explaining how to build executable models. But for our case, we can leave it at that. So now I want to show you another very neat thing. So let me undo the transformation once again, and let me save this 150% model of my coffee machine into the workspace of pure variants. So my workspace is in my user home, so I am quickly navigating to it, and in the coffee machine webinar I'm creating a new directory called input. I'll explain why I'm doing it in a moment, and I'm now saving this 150% model into the space of pure variants. So I'm doing that, and actually let's give it a few moments while it is saved. And now let's simply close this project in Cameo Systems Modeler and once again switch to pure variants and do a quick refresh. So now if I refresh my coffee machine webinar project, in the input here I have my coffee machine webinar project. So why did I do that? So now I will create another model. It's called the family model, and it's basically a collection of all of your artifacts, so for describing your system. So your documentation, requirements, and other 100% artifacts would be described and linked here in the family model of pure variance. And by having it in the family model, from the pure variant side, I will be able to do a specific variant realization without using the Cameo Systems Modeler explicitly. So I want to show you how to do that. So to do that, as you see here, I need to create a family model, and this is pretty straightforward. Let's do it pretty quick. So I need to create a family model, and let's name it Coffee Machine Family. Family, yeah. Clicking finish. I needed to save my feature model for it to work. And in the family, I need to add another component and simply name it a system model. Yeah. And in the system model, I need to specify that I will have a Magic Draw project. And Magic Draw and the Cameo Systems Modeler, in this case, is essentially the same thing. So I need to say that this is my coffee machine system model, and I'm quickly navigating to the file. So in the Pure Variance workspace, in the webinar project, in the input directory, I'm selecting my 100% system model, which I have saved there, this little guy. And this is an important value to set, is to keep constraints. So basically after transformation, do you want to keep the variation points or not? Usually when you have a specific model for a specific product, for a specific realization, for a specific variant, you do not need to have the variation points displayed after you do the transformation. So that's it. I click finish, and in my family model, I now have the system model. And usually you would have your documentation, your requirements from doors, for example, also here in this family. So what did I achieve by this? So if I go now to my variants, to my products, there is a shortcut here to do a transformation automatically. But to do that, I just need to configure a little, some little things, and what I need to do is to save all of the resources that I have and include in the configuration space the family model that I have created and also the coffee machine feature model. I can also specify the default inputs and outputs, so that's why I have placed my systems model in the input directory. And in the last step, I need to add a transformation module. So let's name it, say that this is a Cameo Systems Modeler transformation, and let's add a transformation model. So Magic Draw and Cameo Systems Modeler is essentially the same thing, and I am adding this transformation model. So I have all that I need to have here. So the tool now has the family model, the feature model, and it has the transformation module to transform my system model automatically, right? So if I do that, and in this case we select an Indian product and go to transform and say that I want to do a CSM and create an output product. And now what is happening is that the Pure Variance launches Magic Draw or Cameo Systems Modeler in a headless mode, so without a graphical user interface. And by using all of the information that we have defined here for the feature model, family model, and the variant description model, and by using the 150% system model, it will now realize a specific variant of the coffee machine and produce our system model for this specific variant. In this case, we are realizing the Indian deluxe variant of our coffee machine. So while it's doing that, I once again want to iterate that here you would have your artifacts describing the entire family of your products here. And by doing the simple transformation, the tool would automatically transform those artifacts and produce only the artifacts that are relevant and were cut for your specific product, for your specific variant of your system. So basically, this is the place where you would have it defined. So while it finishes doing that, we also have a few minutes, and while it's doing that, I will now review the questions that you had during this session, and we'll try to answer them.
Thank you, Darius. So yes, now is the question time, and please give us a few minutes while Darius reads the questions and prepares for answers.
And now the transformation was finished successfully, and in the output directory I have a Indian Deluxe realization. So if I double click on it, I will be able to open this specific the specific model for the specific variant in Cameo Systems Modeler. But once it does that, Inga will read a question that I would like to answer.
Okay, so the first question is, in an ideal world, the feature model should be an output from the architecture defined in Systems Modeler. Is there any work in trying to get pure variants to read this information from the architecture defined in Systems Modeler?
And thank you. Actually, this is a pretty good question. And now there is no such a capability implemented, but it would be certainly a nice to have feature. And we are noting this feature down, and maybe in the future releases we'll be able to implement this capability to have an initial export of the feature model from your architecture and from then on used in pure variants. So do we have any other questions?
Yes. Did you have to select the adapter and display since the Deluxe already forced those?
Okay, I know what you have in mind here. Yes, I had to basically confirm the selection. The tool only indicated that this selection is necessary, and if I would have selected otherwise, then once again I would have gotten another validation error. And now if you see the screen, our Indian coffee machine, the variant is already open, and we can see that here that it has a display because it defined it this way, and it also has an universal power adapter. And if I execute this model, I see that this is indeed a deluxe version of my coffee machine, and it's possible to brew all of the coffee types here. But I want to mention just one more thing, that in practice, I would need to have defined way more variation points. I did just a few of them for the demo purposes, because normally you would also have to look over the behaviors and maybe add some variations point to them. But since we unfortunately now are running out of time, so we'll begin by closing today's session.
Okay, thank you, Darius. We have a few more questions, but since we're running out of time, we'll publish the rest of the answers in our webinar's webpage. Thank you all for participating, and we hope to see you again in upcoming webinars.